Hello everyone, welcome back to my YouTube channel. I am Suhas. We are studying second year CSE in Sri Venkateshwara College of Engineering. Today we are going to discuss about mass storage structures in operating system. Contents. First we will see the overview, and next moving head disk mechanism, next hard disk drives, and next non-volatile memory and volatile memory. Let's move on to the topics. Overview of mass storage structures. It is a bulk of secondary storage for modern computers is hard disk drives and non-volatile memory devices. HDD spin platters of magnetically coated material under moving read-write heads. Its drives rotate at 60 to 250 times per second. Transfer rate is the rate at which data flow between drive and computer. Position timing is time to move disk arm to desired cylinder and time for desired sector to rotate under the disk head. Head crash results the disk head making contact with the disk surface, and that's bad. Disks can be removable. This is the structure of the moving head disk mechanism. Next, hard disk drives. The platters range from 8.5 to 14. The commonly 3.5, 2.5 and 1.8 range from 30 GB to 3 TB per drive. It gives good performance and the transfer rate is 6 GB per second and its effective transfer rate is 1 GB per second. Seek time from 3 millisecond to 12 millisecond. The common for desktop drivers is 9 milliseconds. Average seek time measured or calculated based on one third of the tracks. Latency based on spindle is given by 1 by RPM again divided by 60, which is equals to 60 by RPM. The average latency is exactly the half of the hard disk drive's latency. Access latency or average access time is given by average seek time plus average latency. For faster disk, 3 plus 2, that is 5 milliseconds. For slow disk, 9 plus 5.56, that is 14.56. To calculate average input output time, average access time plus amount to transfer divided by transfer rate plus controller overhead. Here we have taken an example, you can refer to that. Next, the first commercial disk drive. In 1956, IBM RAMDAC computer included the IBM Model 350 disk storage system, 5M characters, 50 into 24 platters, access time that is less than or equal to 1 second. Non-volatile memory devices, they are like disk drives, so then they are called solid state disk, SSDs. Other forms include USB drives, DRAM disk replacements, surface mounted on motherboards and main storage in devices like smartphones. They can be more reliable than HDDs, more expensive per MB. They maybe have shorter lifespan. They have less capacity but much faster access. Buses can be too slow, that's connected directly to PCI. No moving parts, so no seek time or rotational latency. Have characteristics that present challenges. Read and return in page increments but can't overwrite in a place. Must first be erased, and erasures happening in large block increments. They can only be erased a limited number of times before worn out. Lifespan measured in drives writes per day. A 1 TB NAND drive with a rating of 5 drive write per day is expected to have a 5 TB per day written within warranty period without failing. Next, NAND flash control algorithms. With no override, pages end up with a mix of valid and invalid data. To track which logical blocks are valid, controller maintains flash translation layer table (FTL). It also implements garbage collection to free invalid page space. It allocates over provisioning to provide working space for GC. Each cell has lifespan, so we are leveling needed to write equally to all cells. Next, volatile memory. DRAM frequently used as mass storage device, but not technically secondary storage because it is volatile. but can have file system be used like very fast secondary storage. RAM drives present as raw block devices, commonly file system formatted. RAM drives under user control, found in all major operating systems like Linux, macOS, Disk-Util to create them. Linux/TMP of file system type TMPFS. It used as high-speed temporary storage, and programs could share birth date quickly by reading or writing to RAM drive. That's all for today's session. Thank you for watching my video. If you like the video, then please like, share and subscribe. Thank you.